Personal finance practice problem using Excel. Excel functions, present value, future value, and number of period functions. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet would like to follow along, note that we're in the Practice tab as opposed to the Example tab. The Example tab, in essence, being an answer key. We have the information on the left. We're going to populate that into the blue area on the right-hand side. But before we do, just notice that this Excel worksheet and possibly your Excel worksheet, if following along, has some hidden columns in it. We just want to note those hidden columns, see what we have done in the past, and be able to hide and unhide columns because that's a useful tool for working around with Excel worksheets. So we know there's hidden columns because the alphabet goes A, B, L, which is not how it normally goes. There's letters missing. So we're going to put our cursor on column B here, left click on it. I'm going to drag over to column L so that we have the hidden cells in between. Let go, right click on that selected area and unhide so that we could see what we did last time, which was the rule of 72 and then a running balance type of calculation. You don't need to have done these in order to continue along, but just note these are different ways we're calculating basically the same thing, which is the information on the left being yearly earnings percent of an investment are 12%. In other words, we expect the investment to be increasing by 12% yearly. And then we're asking the question how long it would take for the investment to double, which we can do without even knowing the original investment, which we're going to then assume to be 2,000. But we got to 6 years. That's an approximation with the rule of 72. And then we assumed the investment starting at 2,000. Then for it to double, it would need to be at 4,000. We ran a running balance to basically show that that would happen sometime between years 6 and 7. This running balance giving us more information. Now we're going to do this in Excel, multiple different ways using functions. So before we do, let's hide these cells back up again. So we have our data on the left right next to our calculations, which will be on the right. A very useful skill to know. We're going to put our cursor on column D, drag on over to column J, or the one right after it, the skinny column, K or H or whatever's after J, right? And then we're going to right click on that selected area and hide them. Hide those columns. So there we have. We're going to be using our Excel functions to look at the unknown, and we're going to be using the present value function, the future value, and the number of periods, all related functions to find the current unknown. We'll also be using goal seek so we can get an idea of how to use that tool as well. So once again, the data on the left says we have the yearly earnings percent of an investment are going to be increasing 12%. We want to know how long it'll take to double. We're then going to assume the investment, the starting point at 2,000. That means for it to double, it would then be at 4,000. So the starting point would be at 2,000. We want to get the ending point sometime in the future to be 4,000, and we want to know how long that will take. Now, if we have that question, then the most common functions that we'll be using most likely will be the present value function and the future value function. Those are the two functions most people know best. But the function itself, for example, on the present value function is designed just like an algebraic equation to give the answer of the present value, which here is known. The present value is 2,000. What we're trying to find is the number of periods. But within this function is the function of a number of periods, which is similar to an algebraic equation, which has one unknown. And as long as there's only one unknown, we could still use the algebraic concept to back into what that unknown will be. And so we'll do that, and we'll do that using basically a goal seek function. So instead of reformatting the equation, we'll use a goal seek function, which will basically use trial and error to use that same algebraic concept to search for the one unknown. So we're actually going to start this time down here with the present value calculation, because that's probably the first calculation that comes to most people's minds. And then we're going to back into the unknown using our goal seek. Then we'll do the same thing for the future value, that helping us to see how these formulas are related, functions are related. And then we'll go to the most straightforward but least well known of the three functions with the number of period function, which is actually the direct function that would be used to find the answer kind of most clearly or most easily. Okay, so let's start with our present value calculation. We're going to enter the function. Now, last time In the first problem, we used the dialog box to do this and went back and forth between the dialog box and just entering it straight out. The dialog box can be found by going to the formulas up top in the functions library section, and then the insert function, you could find the dialog box up here. I'm not going to do that this time because I think it's useful just to know how to enter this data using a straight formula. And so I'm going to just enter the straight formula. So I'm going to go back to the home tab up top, which is where we usually want to be if we're not, using our ribbon up top. Going to go down here and I'm just going to type in equals present value. There's our formula. We could double click on it down below, or we can hit Shift 9, putting the brackets in place. And then here's our series of data that will be separated by commas that we just want to get used to entering in this format. And we'll be able to kind of figure this out as we go, as Excel sees it, using kind of like the code of Excel down here, the kind of computer code, the language of Excel with this little dialog box. So we got the present value. We're going to pick up the rate. Now I could just type in the rate at 0.12, but I want to pick it up from our data on the right-hand side, on the left-hand side. So I'm going to select this cell, which is cell B2. There's the rate. I'm going to put a comma, which will take us to the next argument or the next component, the number of periods. Now that number of periods is what we do not yet know. So what I'd like to do is put something there. I want to put something that's in this box there. Notice it's blank right now because that's the unknown. That's what I would like to back into. So also note there's a couple ways that we could do that. I could look for another function in Excel, which would be the NPER function, to get to that number directly. Or I could use the algebraic concept here of saying, hey, that's the unknown. As long as I only have one unknown, I'm going to back into it by using a trial and error function. I won't rework the equation, but I'll simply use trial and error. So I'm going to pick a number here. I'm going to keep it at 0 or add some number there first, and then I'll go back in there and adjust it. So then I'm going to go to the next argument, which is going to be the payment. The payment is used for an annuity calculation. And we're not talking about an annuity because there's not multiple payments here. There's only basically one amount that we're trying to see how much it will grow by if it was just growing by an average or same amount. So you could then put 2 commas here, or you could put a 0 and a comma. Last time we did the 0. Once you get used to this, you're going to want to just do 2 commas. That's the more professional thing to do, which will take you to the next argument. The future value, where we expect to be at the end, we know to be 4,000, because if we were going to double this 2,000, we need to be at 4,000. I'm not going to type in 4,000, but rather I'm going to select cell 2,000 times 2 to keep with the practice of taking the data from our information on the left. Now I could simply hit enter and it won't give me an error, I do not believe, but I should close up the brackets, which is Shift 0. That'll close the brackets and enter. So there we have it. It gives us a negative number here. So we don't want a negative general. So I will typically change the sign by double clicking on it. And then a lot of people will argue that you should put the negative in the number of periods, the payment calculation or the future value calculation. But I'm just going to put it right before the P, flipping the sign of this thing. That'll basically multiply it times -1, or you could think of it just simply flipping the sign, and that'll give us a positive 4,000. Now that equation doesn't quite work if I'm using a cell that has nothing in it. So what I'd like to do is put something, just guess a number here, like 5, and then see what the result will be. We're at the 2,270. So what I'm going to do then is say, well, what if I guess like 5.5 or something like that? Now we're at the 2,145. What if I select, 7? Now we're at the 1,802. What we want to do is to get this cell to be where it needs to be to get that number then to 2,000. Then we can use a goal seek function in order to do that, which will just basically use trial and error instead of reworking the algebra. So I'm going to go back up top and do that by going to the data tab. Notice I'm not on any of the cells. You don't need to be on a cell. I typically don't like being on a cell that I'm going to be working in because this isn't entering in a new function. It's just going to change the relationship of the numbers that are already in place. So we're going to go to the forecast, what if analysis. We want to go to goal seek. And then I'm going to say we're seeking the goal. We want to set this cell to be what we know it should be. This is the present value, meaning I put in the formula that it's going to end at 4,000. I want to bring it back to 2,000 here. So that I want the ending result to be 2,000. by changing then this number right there on the goal seek. And then we're going to say OK. And it does that for us. We're at the 6.12, which is close to what we got with the rule of 72. This number is a bit more exact. Notice it might not be exactly 2 decimals out. If I go to the home tab and I add some more decimals, it's a longer number than that. We'll round it to basically 2 decimals. I'm in the number group, adding and subtracting decimals. Now we can do a similar situation with the future value. So the future value, we can have the same concept, and that'll hopefully give an idea of how these two functions are related. So this is the second most well-known function, depending on what you kind of use your calculations for. Let's do the future value calculation. Once again, you could do that with a dialog box, formats up top, the insert function. This will give you kind of a cheat screen somewhat that we saw last time to help you to understand it possibly in a little bit more depth. It doesn't add a whole lot, and it's not as quick to enter, so you really want to understand how it looks when you just enter the data. So I'm going to go back to the home tab and not use the dialog box this time, and just simply enter this in like we want to get used to being able to do by saying equals. So anytime we have a function or a formula, we're going to say equals and then FV. That'll bring up our functions. There's the future value, which I could double click on, or I can say Shift 9, putting the brackets, which takes us into the future value calculation. Our argument box down below. We've got then the rate, which we could type in at 0.12, but we want to take this from our data set on the left, clicking on the 12%. Comma, taking us to the next argument, which is the number of periods. That's the unknown. That's what we do not know. We're going to just select this cell, which we're then going to populate with some data, and then use our trial and error and goal seek to find that unknown. Comma, the payment that we have, that's going to be a term that we'll use if we have an annuity calculation. This is not an annuity, but a future value of 1 calculation. So I can either put a 0 in a comma, or more professionally, just simply 2 commas, which will take us to the next argument of the present value, which is the starting point, our 2,000. So we're starting at the 2,000. We want the end result to be 4,000 because we want it to be doubled. Now then I could close this up with brackets, Shift 0, or I can leave it open and Excel will basically close it up for us, saving us, a keystroke at the end. So I'll just leave it open and say, okay, enter, and there's our 2,000. Now if I double click on this again, going back into it, there's our bracket at the end. It added it for us. We then want to make it a positive number. We could do so by putting this argument, having a negative here, negative in the present value, or we could put a negative in front of the F, which is what I just typically do to kind of flip the entire argument or the entire function, multiplying it by -1 in essence. There's the 2,000. Now this number isn't accurate really because we don't have anything in this box. So I'm going to put in like 5 just as a starting point. Now we have something there. Once again, we can then use trial and error to get this end result to what we need it to be, which is 4,000, because we want to get this doubled to 4,000 and know how long it would take to get there. So 5.5 and so on, 5.8 would get us closer and closer. We could use goal seek, which I'll typically click off of any box here to get Excel to do that for us. We're then going to go to the data tab up top, forecast group, what if analysis, goal seek. And then we're going to ask Excel, we're going to say, Excel, would you please set this cell to be what we need it to be, the end result, answer 4,000, by changing the cell that we want to find, which is that 5.8, to whatever periods or years it would need to be to get to that end result. So we'll say okay, and it does it for us. There it is. There's the 4,000, and once again we get to this 6.12. So you can kind of see how these two functions are related to each other, of course. And now we could say, okay, well, the fastest way I could go there, the other way I can do this is, instead of me kind of backing in and using goal seek, I could say that's the unknown right there. That's what I don't know. Why don't I see if Excel has another function where they kind of do the algebra for us, right? I can't rework the function myself algebraically like I could if I had one unknown in algebra, but I can look for another function which you would think Excel would name that NPER, since that's what they named the argument, which of course they do. So let's do it that way. I can say this would be the most direct way, but probably the least common function that we would actually use, and one that you may not kind of visualize as well in your mind on what it is. So in any case, we're going to say equals the NPER. Note, you can also look for this other function in the formulas tab in the dialog box up top, but we're practicing simply typing them in this time. So I'm going to double click on it. Hold on a second. You can double click on it, or you can hit Shift 9. That'll take you into the argument. Let's do it one more time because I kind of bobbled that one, kind of messed it up. So let's try it again. Equals NPER. So you can either double click on it here, or like the other arguments, you could say Shift 9. That'll take you into the argument. We want the rate then. The rate's going to be the 12%. I'm not going to type in 0.12. I'm going to click on the 12% in our data set, comma. The payment then, there is no payment because we're not talking about an annuity, but a fact, a one kind of component. So we're going to say comma, comma. You can put a 0 and a comma to get to the next argument, or more professional, two commas. The present value, our starting point, is going to be that 2,000, and comma, the ending point is going to be 4,000, which I'm not simply going to type in there, but rather take our information from the data set as much as possible, picking up that 2,000 times 2. Then I can close this up, Shift 0, or I can leave it open, and Excel will close it for us. So I'm going to say Enter, and there we have it. Now note, it gave me an error here. That's not because I didn't close it. If I double click on it, it closed it up for us. But Excel wants a negative number somewhere, and it wants the negative number, I believe, in the present value tab. So if you get an error like that, and I'm not going to get into the technicalities of why that is, but just realize that it usually wants a negative number in the present value when you look at some of these present value calculations. If you're looking at these two down below, like we did, it'll give you a negative number, and you can flip the sign by putting the negative before the full function. But some of the other present value calculations, they're going to want an argument to be negative to populate properly. So I'm going to put a negative here and then Enter, and there we have it. There's our 6.12. So there's those multiple ways we can kind of figure this. Now note, as we look at those calculations, they still are not, these are the fastest way that you can do these. In practice, this is what you would probably do. In a test situation, then they might make you do it with an algebraic equation and or with tables, or use the rule of 72. And then also in practice, notice that you'd still want that running balance ability to do the running balance calculation, because this is still kind of a magic number. People will learn to calculate this number and have no idea what that means or how to apply it to decision making. And if you do the running balance calculation, that'll usually give you a better idea of what is actually happening and how this could be useful for you in practice with actual decision making.